Class 10th Science Chapter 3 Metals and Non-Metals. Metals. Metals in the pure state have a shiny surface. This property is known as luster. Metals are generally hard. Metals can be beaten into thin sheets. This property is called malleability. Metals can also be drawn into thin wires. This property is known as ductility. Metals are good conductors of heat and electricity. Metals, when struck with a hard surface, produce sound. This property is this is because metals are sonorous. Non-metals. Non-metals are very few compared to metals. Some of examples of non-metal are carbon, sodium, sulfur, iodine, oxygen, hydrogen, etc. Non-metals are either solid or gas in nature, except bromine, which is a liquid. Properties of metals and non-metals. All metals except mercury exist in solid at room temperature. Iodine is a non-metal but it is lustrous. Carbon is a non-metal that can exist in different forms. Diamond, an allotrope of carbon, is the hardest natural substance known and has a very high melting and boiling point. Alkali metals are so soft that they can be cut with a knife. They have low densities and have low melting points. Almost all metals combine with oxygen to form metal oxides. For example, when copper is heated, it combines with oxygen to form copper oxide. But some metal oxides such as aluminum oxide, zinc oxide show both acidic as well as basic behaviors. Such metal oxides which react with both acids and as well as bases to produce salts and water are known as amphotic oxides. Most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Sodium oxide and potassium oxide dissolve in water to produce alkalis. Different metals show different reactivities towards oxygen. Metals like potassium and sodium react so vigorously that they can catch fire when kept in open. Metals react with water and produce a metal oxide and hydrogen gas. Metal oxides that are soluble in water dissolve in it to further form metal hydroxide. Metals like potassium and sodium react violently with water, cold water. In case of sodium and potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. The reaction of calcium with water is less violent. Heat is evolved, which is not sufficient for the hydrogen to catch fire. Calcium starts floating because of the bubbles which made by the hydrogen gas. Magnesium does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminum, iron and zinc do not react either with cold or hot water, but they react with steam to form metal oxide and hydrogen. Metals such as lead, copper, silver and gold do not react with water at all. Metals react with acids to give us salt and a hydrogen gas. Hydrogen gas is not evolved when the metal reacts with a nitric acid. It is because nitric acid is a strong oxidizing agent. It oxidizes H2O produced to water and itself gets reduced to any of the nitrogen oxides. But magnesium and manganese react with very dilute nitric acid to evolve hydrogen gas. Reactive metals can displace less reactive metals from their compounds in solution or molten form. If metal A displaces metal B, then metal A is more reactive than metal B. Reactivity series. The reactivity series is a list of metals arranged in the order of their decreasing activities. The most reactive metal is potassium and the least reactive metal is gold. Properties of ionic compounds. Ionic compounds are solids and are somewhat strong because of the strong force of attraction between them. Ionic compounds have high melting and boiling point. This is because the considerable amount of energy which is required to break their structure. Electrovalent compounds are generally soluble in water and insoluble in solvents such as kerosene, petrol, etc. The conduction of electricity through a solution involves the movement of charged particles. A solution of an ionic compound in water contains ions, which move to the opposite electrodes when electricity is passed through the solution. Ionic compounds in the solid state do not conduct electricity because movement of ion in solid is not possible due to the rigid structure. But ionic compounds conduct electricity in their molten state. Occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains some soluble salts such as sodium chloride, magnesium chloride, etc. Percentage of a particular metal. Minerals contain a very high percentage of a particular metal, and the metal can be profitably extracted from it. These minerals are called ores. Extraction of metals. Some metals are found in the earth's crust in the free state. Some are found in the form of the compounds. The metals at the bottom of the activity series are the least reactive. They are often found in a free state. For example, gold, silver, platinum, etc. Copper and silver are also found in the combined state as the sulfur or oxide ores. The metals at the top of the activity series are so reactive that they can never be found in natural or as free elements. The metals in the middle of the reactivity series are moderately reactive. They are found in the earth's crust mainly as oxides, sulfides, or carbonates. You will find that the ores of many metals are oxides. This is because oxygen is a very reactive element and is very abundant on the earth. Thus, on the basis of reactivity, we can group metals into three following categories. First, metals with low reactivity. Second, metals with medium reactivity. And third, metals with high reactivity. Enrichment of ores. Ores mined from the earth are usually contaminated with large amounts of impurities such as soil, sand, etc., called gangue. The impurities must be removed from the ore prior to the extraction of the metal. Extracting metals low in the activity series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. Extracting metals in the middle of the reactivity series. The metals in the middle of the reactivity series, such as iron, zinc, lead, copper, are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. The sulfide ores are converted into oxide by heating strongly in the presence of oxygen. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The metal oxides are then reduced to the corresponding metal by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it reduces to metallic zinc. Besides using carbon to reduce metal oxides to metals, sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminum, etc. are used as reducing agents because they can displace metals of lower reactive series from their compounds. Extracting metals towards the top of the activity series. The metals high up in the activity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot produce the oxides of sodium, magnesium, calcium, aluminum, etc. to give respective metals. This is because these metals have more affinity of oxygen than carbon. These metals are obtained by electrolytic reduction. Refining of metals. The metals produced by various reduction processes described are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is called electrolytic refining. Electrolytic refining. Many metals are refined electrolytically. In this process, the impure metal is made at the anode and the thin strip of pure metal is made the cathode. A solution of metal salt is used as an electrolyte. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. Corrosion. Iron, when exposed to the moist air for a long time, acquires a coating of a brown flaky substance. This is called rust. This is an example of corrosion. Prevention of corrosion. The rusting of iron can be prevented by painting, oiling, greasing, galvanizing, chrome painting, anodizing, or making alloys. Galvanization is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. The galvanized article is protected against rusting even if the zinc coating is broken. Alloying is a very good method of improving the properties of a metal. We can get the desired properties by this method. For example, iron is most widely used metal, but it is never used in its pure state. This is because pure iron is very soft and it stretches easily when it is hot. But if it is mixed with a small amount of carbon, it becomes hard. Mixed with a small amount of, it becomes hard and strong. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. It is prepared by first melting the primary metal and then dissolving the other elements in it in definite proportions. Then it is cooled to room temperature. One of the metals is mercury. Then the alloy is known as amalgam. The electrical conductivity and melting point of an alloy is less than that of a pure metals.